In this video, we are going to use electronegativity values to determine if a bond is polar or nonpolar. First, let's talk about electronegativity. Electronegativity is the measure of the tendency of an atom to attract a bonding pair of electrons. So remember, a bond is actually two electrons being shared between the two atoms. Some elements hold that pair of electrons a little bit closer to them, and this results in that element having a slightly negative charge. The other element, by default, has a slightly positive charge. Electronegativity always increases as you move right across the periodic table and up a group. This results in fluorine being the most electronegative element. Francium is our least. You'll notice that the noble gases are not contained there. That is because they don't have electronegativity values, because they don't bond. When we talk about our types of bonds, we have to first determine the difference in electronegativity. And we do this by taking the larger electronegativity value and subtracting the smaller. And then we consult this chart to look at the difference. If the difference is less than 0.5, we say that that bond is nonpolar. So that means that that pair of electrons is equally shared between the two bonding elements. So you'll notice in the picture that we have two hydrogen atoms and they're playing tug of war. They're both happy because they're both equally strong. And so those pairs of electrons are just held evenly spaced between the two elements. If the difference in electronegativity, however, is greater than 0.5, we say that that is a polar bond. And this means, like you can see in the picture of hydrogen and chlorine, chlorine has a larger electronegativity value. So it's like the strong man in the tug of war race. And it's holding the pair of electrons a little bit closer to it, and hydrogen is kind of weak, and it has the electrons further away. Let's examples. So if we look up the electronegativities for hydrogen and bromine, hydrogen has an electronegativity of 2.1, bromine has an electronegativity of 3.0. So if we do the big number minus the small number, we get a difference of 0.9. I think we can all agree that 0.9 is greater than 0.5. Therefore, these bonds are polar. When we say that the bond is polar, we need to use the Greek deltas to indicate which element is slightly negative and which end is slightly positive. And we do this by looking at our electronegativities. Because bromine has the larger electronegativity, it's like the strong man playing tug of war. So it holds the electrons closer to it. So we use the Greek delta with the minus to indicate that the bromine is slightly negative. This means that the hydrogen is slightly positive. If you are watching this video and you are in grade 12, you are using dipole vectors. Dipole vectors will show the arrow pointing towards the more electronegative element, and then we put a positive on the lower electronegative element. So if we look at carbon and hydrogen, carbon's electronegativity is 2.5, hydrogen's is 2.1. So if we do 2.5 minus 2.1, we get 0.4. 0.4 is less than 0.5, therefore these bonds are nonpolar bonds. When you have nonpolar bonds, you do not indicate a negative or positive end because the bond is nonpolar. That means there is no negative or positive end. In our last example, we have the nitrogen-hydrogen bond. So nitrogen has an electronegativity of 3.0, hydrogen has an electronegativity of 2.1. So if we do the large number minus the small number, we get 0.9, which again is larger than 0.5, which means that this is a polar bond. And we're going to indicate which element is slightly negative, and that would be our nitrogen because it has the larger electronegativity value, and hydrogen is going to be slightly positive. Again, if you're in grade 12, you are going to be drawing the arrow towards the nitrogen and putting the plus on the hydrogen. I hope this has helped you learn the difference between polar and nonpolar bonds.